Okay, we're talking about quadratics. A quadratic equation is one of those kind that has a little squared in it. And the official math way to say that is this. Please read it over briefly. Because in pre-calc you can't just gloss over the details. So what's something that's not real? Anything that's not a real number is called a what number? Imaginary. So you can't have any imaginary numbers in these. Okay, the roots of them can be imaginary. That's different. But we're A, B, and C. This, and this. Those aren't the roots. If those are imaginary numbers, it's not okay. You can't have a square root of -3 here because that would be an imaginary number. It's not allowed. Okay, and the other big restriction is A cannot be equal to 0. Because otherwise, if that was 0, then 0 times x squared would mean the whole first term would be what? 0 would be gone. And then it wouldn't have a squared on it anymore, would it, if that was gone? Then it wouldn't really be a quadratic. That's all they're trying to say. All right. Now, standard form says that the terms are in descending order of degree, and the equation is set equal to 0. So, when you're looking at one that looks like this, is this in standard form? Nope, because it's not in descending order and it's not equal to what? 0. All right, I want to talk about why we do that. So we could have a quadratic like this, y equals x squared plus 2x plus 1. But why do we set it equal to 0? Well, we set it equal to 0 because we want to find the roots, which are also known as the x-intercepts. Complete this sentence for me. The x-intercepts are found where what? Y equals 0. That's one of those things that should have been pounded into you last year. The x-intercepts are where y is 0. So that's why I make this 0, because I want the x-intercepts. The x-intercepts of the graph, you know, of these things, remember those? Those are the roots. Those are also the solutions. They're also called the zeros. All right. So I can get those answers a couple of different ways with quadratics. Once I got it set right, once it's in standard form, which it is now, I could say equals 0 at the end or at the beginning, either way. Then if I could factor it, there's a really easy way to get the zeros. This one will factor nicely. What and what? What goes here? What goes here? Plus 1 and plus 1. And then I'll have what would make this part 0 if x was -1. And what would make this part 0 if x was -1? So the answer is -1. Why are there two roots that are exactly the same? It's because here's the -1. And if I graphed this, it would look like that. Do you remember how that's called a double root right there? Okay, it had a multiplicity of 2. All right, all things that you learned in higher algebra. So since that is a bounce, it's a double root. It's double of -1. It's because there's 2 right here. One here and one here. All right. So when we're doing quadratics, that's a great way to solve them, is to factor them. And let's say it factors down and looks like this when it's done. X plus 3 and 2x plus 1 equals 0. Okay? Now I can use that zero product property. Write that one down and tell me the two answers. There's the easy one. What's the answer for that part? -3. And the other root over here is a little harder. And if it doesn't just come natural, for some of you are like, oh, it's -1/2. You can just see it. For those of you that can't, set it equal to 0. 2x plus 1 equals 0. Then 2x equals -1. And then I divide by 2 on both sides, and x equals -1/2. Do you get that? All right, good. So that is solving a quadratic equation by factoring it and getting the two zeros that way. Here's one of the zeros, and here's the other 0. Also known as the x-intercepts or the solutions or the roots. Those are all words for the same thing. Okay. So then what other kind of no, I don't want to clear fractions yet. What other kind of quadratics are we going to run into? Well, we're going to sometimes run into quadratics that look like this. First of all, is that in standard form? What are the two things it has to be? It has to be set equal to 0, right? Is it set equal to 0? Yes. And it's supposed to be in order from the biggest to the smallest degree. Is it? Yes, it is. And it's okay that there's no missing middle term. This is still in standard form because the rule was it has to be in order from the biggest degree to the smallest degree. This is degree 0 and this is degree 2. It's in order. It just feels weird because it doesn't have a middle term, but that's okay. So then, how do I solve this? Well, this kind, you can graph it and see where it crosses. Same deal. This one would cross the x-axis, and so it'd have 2 roots. And your graphing calculator could do that for you. Otherwise, you could factor it if you can. But we can't factor a sum of squares. We're supposed to only do that with difference of squares, so I can't factor it. Actually, wait a minute. No, this one would not have real roots. I'm wrong. I couldn't factor it, and I couldn't graph it. The only thing I could do to find the roots is the other way you can do solve quadratics. You can factor them, you can graph them, and the other thing, and this is stuff I'd write down on my notes, the 3 ways you can solve quadratics. One is you can factor them like this. I'd write yourself one of these. You can graph it and find the x-intercepts. Or the third way, it's the only way that I know of that you learned with a song. Yes, the quadratic formula. X equals negative b. Remember that one? Okay. And opposite of b plus or minus the square root of b squared minus 4ac. Almost can't help myself. All over 2a. Remember that? Remember how that song starts? What's the first 2 words? X equals. So we're finding x-intercepts. The y I already know. If it's an x-intercept, I know the y is 0. So I'm trying to find the x. So I take this little formula and I plug in a, b, and c from this. Well, by the way, what's b? B is 0. Okay. And a would be 1 and c would be 144. And I could do it that way. That would work fine. Okay, well, you would find out that this has a negative under the square root, and that's one of those times when you have imaginary roots. You can't have negatives under here, remember? At least not to have real solutions. So one other way, this is a special kind that doesn't have a middle term, and it has one other way you can solve it. If I had to know what x was, I can just simply get x alone, right? And since this doesn't have a middle term, it ends up working out pretty good. You can just go minus 144 from both sides. X squared equals negative 144. And right away, as far as the real numbers go, you have to be able to say, wait a minute. Would I ever square something and you end up with a negative? No. That's why the answer is imaginary. But I can do a square root here. And the square root of x squared would be absolute value of x equals negative the square root of 144. Do you remember how we write that? 12 what? 12i. And absolute value of something means that you end up with 2 answers. Plus 12i and minus 12i. Because remember how stuff on the absolute value, it can either, whether it's positive or whether it's negative, it'll come out with the same answer. All right. So this one I could do this last way, which is algebraic. So there's actually 4 ways you can solve a quadratic. You can solve it algebraically like this, just by simply setting x equal to, getting x alone. I got x alone, I got it solved. But that doesn't work so good when you have a middle term. And that's where you should either use graphing, and you just use your graphing calculator and find where it touches. Or you use factoring, factor it out, make it equal 0, and then these answers are pretty easy to find. All right. So there's your quick summary of quadratics. So now if I go back to that page full of problems, I want you to try D right here. First of all, get it in standard form. Nothing starts till you got it in standard form. And then from once you got it in standard form, it shouldn't be too bad to factor it is the way I'd start. So did you get x squared minus 2x, and the negative 3 was there, and I get another negative 12 because I'm taking away 12 from both sides. It makes negative 15. Do you agree? Okay, and it should equal 0. And then from there, I go equals 0, x, and then what number goes here and here and multiplies to negative 15 and adds to negative 2? Negative 5 and positive 3. Excellent. Then that means the answers are x equals what for that? X equals 5, and x equals what for that? Negative 3. All right, so there's your two solutions. Okay. We're not going to try to do every problem here. That'd be crazy. How many had that one right? Raise your hand if you did. Good. Now, if it had come out so that you couldn't factor it, then you go to one of your other methods. What's one of the other methods I mentioned? Graph. You graph it on a calculator. You find where it touches the x-axis. What if you don't have a calculator around and you haven't, and you try to factor, but you can't? Can't factor, can't seem to be able to graph it because you don't have a calculator. Quadratic formula. Very good. All right. And if it's one of those kinds that has no middle term, like this one would be, there'll be no middle term because there's no like 2x, then that kind can be solved with just algebra. You'd subtract 12 from both sides. I'd have x squared equals negative 12, and right away you should know, wait a minute, there's not going to be any real answers because you can't square something and get a negative, but you could still have an answer of the plus or minus the square root of negative 12. All right, let's move on. Another important skill you need to know is clearing fractions. As you're getting to these problems, there'll be some with fractions in them that are just kind of a bear, but I want you to understand how to clear them and make the problems so much easier. If you know this method, you don't have to mess with nearly as many fractions. All right, I'm going to show you something, and I'll see if you agree with the statement. Would you agree if I said 2 plus 3 is equal to 5? Then I should be able to times, if this is a true equation, if I multiply by anything and I multiply every term by it, then it should stay true. What if I multiply everything by 3? 2 times 3 is 6. 3 times 3 is 9 equals 5 times 3 is 15. Still true. See? I can multiply by anything I want. Well, if you had a problem like this, 1/4 plus 2/4 equals 3/4, and I wanted to multiply by anything I want, what number could I multiply by that would get rid of the fraction and make it like it doesn't even exist? Times by 4. Times by 4 here, here, and here. All of a sudden I got 1/4 times 4 is 1, plus 2/4 times 4 is 2, equals 3/4 times 4, which is 3. 1 plus 2 equals 3. It's still true. So you can use that trick to get rid of fractions. If you multiply by that denominator that's annoying you, you will get rid of the fraction. So if I gave you a simple one like 1/2 x equals 12, and I didn't want to have to deal with the fraction anymore, what could I multiply by? 2. Okay, I multiply by that denominator and times this by 2 and times this by 2, and I will have x is equal to 24. What really comes in handy, though, is in problems like the one I just had up a minute ago. I should go back to it because it's all neat and nice. That one. 1/2 x squared plus 1/5 x equals 4, where you have two different denominators, and it seems like you're going to have to somehow try to like add them or find a common denominator. Don't. Just multiply by something. If you multiplied by 2, you'd fix this one, but it wouldn't fix that one. If you multiplied by 5, you'd fix that one, but not that one. So what you do. Come on, somebody can pull this off. Multiply by 10. That's right. Instead of multiplying by 2 and then multiplying by 5, why don't you just multiply by 10 right off the bat? And then I go times 10, times 10, times 10. And I'd have half of 10 is 5x squared. 10 times 1/5 is 2x. And 10 times 4 is 40. And now, voila, I have a true statement that is fraction-free. See what I did there? So you multiply through by the common denominator. What's a common denominator for thirds and sevenths? 21sts. So I can multiply by 21 here, and here, and here. Question from the back. Yep. No, it's not solved, but at least there's no fractions anymore. Okay, from here, I'd have to solve it by going 5x squared plus 2x minus 40 equals 0. And then I'd have to either factor this or put it in the calculator, or, you know what I mean? But at least I don't have to deal with the fractions anymore. Okay, so on this one, I'm timesing by 21. 1/3 times 21 gives me 7x plus 1/7 times 21 gives me 3x. 4 times 21 gives me 84. Again, like somebody said before, we're not done. It's just that now there's no fractions. Oh, it's really easy. 7x plus 3x makes 10x equals 84, and so x must equal 8.4. It won't be hard to finish them once you do get rid of the fractions. All right, so let's try one of those for you. 1/6 x plus 2/3 x equals, let's see, 1/12. Figure out something smart to multiply by so that you don't have to deal with fractions anymore. What did you multiply by? Would 6 work? No, because it wouldn't fix this. What's a good common denominator? 12 times everything by 12. 1/6 of 12 is what? 2x plus 2/3 of 12. I think it's bigger than 4. I think that's 8. If I had to know, I'd go like this. 2/3 times 12. I'd go like that. 2/3 of 12 means 2/3 times 12. And then I can do some canceling. 3 goes in here once, 3 goes in here 4 times, and 4 times 2 is 8. Get that? Equals 1/12 times 12 is 1. And look at that. 10x equals 1. X equals 1/10. Raise your hand if you had that run right. Okay, good. Vast majority. All right, so are you getting how to clear fractions out? Just times by a whole number that's big enough so it fixes your problem, and you use the common denominator. In this case, of these denominators, we chose 12 to multiply by. All right, then let's get to the next topic, which is triple inequalities. We just briefly talked about that. Same thing applies. If you wanted to get the x alone here, I've got a fraction in my problem. What do I do? Come on, just say it. Multiply by what? Multiply by 5. But the key in these is there's 3 parts. I got to multiply by 5 here and here and here. Final, 2 times 5 is 10. It's less than or equal to 1/5 times 5 is 1x, or just x. Is less than or equal to 5 times 4 is 20. That is solved as good as it's going to be because x is alone. And get that? So if you have a triple inequality like this, it's not really called a triple inequality, but I like to call them that, where you got 3 parts to it. Just whatever you do, multiply by something, add something, you always do it to all 3 parts. Would you please try this one at your desk right now? All right, we're back. I hope you multiplied by 6 or something even smarter. -6 would have been even smarter. Why? Because then you get rid of the negative all at once. Otherwise, if you'd have multiplied by just plain 6, you'd have had negative x in the middle, which would have been a little bit of a pain. So we have -6, and we have -1/6 times -6 makes +1, so it's just x. And the last number is -24. And did anybody notice that because we are multiplying by a negative, we have to switch the sign? Raise your hand if you remembered that. All right, excellent work. If you ever multiply or divide by a negative, which you'd have to eventually to solve this problem, if you multiply or divide by a negative, then you have to switch the signs around to be opposite of what they were. All right, application problems for quadratics. Basically, there's, I want to go through these fairly quickly. This is one where they've given us an equation that models this ball flying through the air. And this is the 102 feet per second is right here in the equation. It says it's 60 feet high, but it's got a 65 here, so I don't know exactly why. But anyway, we can trust that this is our equation to use to start with. So what do I do with it? They asked me for this. What is the height of the ball after 3 seconds? Do you think I should stick the 3 in for the T or the H? A 3 is a time, yes. So I put it in under T. And once I have stuck in a 3 in all of these spots, then I'd have my answer. And it'll tell me how high it is off the ground after 3 seconds. This is a weird one. What happens if the height is actually negative? What does that mean about the ball? Picture the flight of the ball, and then it comes down. And after, what if the balls actually hit the ground at 2 seconds? And after 3 seconds, wouldn't your calculator think that it was like, here, ball going up, coming back down. After 1 second, 2 seconds, after 3 seconds, it'll think it's at a negative height. You see what I mean? In the real world, though, after 2 seconds, let's say, it's hitting right here. It's hitting the ground. Okay, so if you ever come up with a negative for the height, it probably means that it thinks that the ball is under the ground, which doesn't make sense, which means that your time is messed up. They're telling you a time that's not possible. All right. One more type of problem. How long after does the ball hit the ground at the base of the cliff? Now, what they're trying to ask, the English there is not great, but if it goes to the ground eventually, they're asking for that spot right there. Think about it. That's a parabola. What's that spot called? Come on. Yes, it's the roots or the x-intercept. The roots and the x-intercept and the solutions are all the same thing, and I just told you 4 ways to solve that, remember? This is a quadratic. So there were several ways. Matt, give me one way I can solve a quadratic. You can graph it. So I could stick this in my calculator right now and see if I can find that spot on the calculator. And then I'd use the trace button to actually get exactly there. Okay, we haven't done that in a while. I'd like to stop for a second, and if you have your graphing calculator with you, would you please take it out and type that into your calculator. I'm going to pause while you do that. Remember to use a negative sign at the beginning here and not a minus sign by accident, because it'll be an error. That sign, make sure you use the negative key. And in case you've forgotten, this is always in your calculator is going to assume it's in x, so you can use an x squared instead of a t squared. They kind of interchange. So this is about 7 point something. About 7? 7.6-ish? Okay, that's good. Good enough. So that means if this equation is right, then the height of the ball after 3 seconds... No, wait, that was a different question. That was this one. How long after does the ball hit the ground at the base of the cliff? All right, this was 60 feet up, so it's a pretty high up cliff, and then they shot the ball with something like a cannon because it's going pretty fast. Either that or it was like it's 102 feet per second, so I got to think that's like a really hard fastball. So it would be up in the air for a fairly long time. All right, so about 7.6 seconds. That's this distance, because the height is 0, of course. All right, so really what it boils down to on this kind of problem is if they ask you a question about a parabola, they're either usually going to ask you for what's the highest it ever went. That's called the vertex. You can find the vertex of the parabola also by getting in between it on your calculator and finding the maximum between that in that little zone. I don't know if you remember doing that last year. You can also be asked about when does the ball hit the ground? Classic question right there, and they're asking you for the root. You can use the quadratic formula, you can graph it. And the last thing is they'll tell you after a certain number of seconds, Like right here, at time equals, let's say, 3 seconds, how high is it up? And that's one where you just plug this number into your formula for x. Okay? All right. So that's a lot about quadratics. There's another application problem. I guess I'll go through just this one more. If I start with this, a equals 0.3x squared plus 8.9x plus 61.8, where x represents a year, that tells me this is a time, and a is an amount. Then if they give me an amount of minutes, that's not the time we're talking about, is like what year it is, not minutes time. This would go in here, and then I'd have 275 equals 0.3x squared plus 8.9x plus 61.8. So basically I've got my formula. Now it's not in standard form, so you'd subtract 275 from both sides, and then it's just like all the other ones. Is this going to be fun to factor with all those decimals in it? No. You probably don't want to do that. It's probably not going to be fun to graph either, but if you had a graphing calculator, it could work. Last option is you could use the quadratic formula on it once you've got it in standard form, which again starts with 0 equals, or ends with equals 0. Okay? All right. That's a lot of stuff, but I think we've covered everything we need to know. The quiz is not tomorrow. The quiz is the day after tomorrow. So tomorrow we'll do a couple more little things in class to help you prepare. The homework for tonight is to finish the packet that you have already.